So let me start with this presentation on FlexScale, but first of all, let me give the, let's say, the thank you to all the authors who have contributed. So I'm going to present basically some discussions that we have had in the framework of this project, FlexScale. So that's why here you can see a long list of contributors from CTTC, but also from UBTech, so Panagiotis is over there, and also from Kenit, from Espoir Santana and Kenit, that in fact this morning Nicole has already presented also another contribution that has also been carried out in the FlexScale that is related to this one, as you will see now. Okay, so let me briefly introduce a little bit the project, just to have a better background and a common understanding on what we are doing in this project. So first of all, it is a quite large project, as you can see here. It is composed by 15 partners, and that basically we are covering very large companies. So we have vendors, we have telecom operators, we also have research institutions. And basically, this is a project that has started just, let's say, this year, so in January of this year, and we have 3 years ahead of us. So one of the main contributions of this project, let's say, is to increase the capacity at the network level. So that means that on the one hand, we are targeting to, well, basically there are two main developments at the hardware level. The first one is to increase the switching capacity beyond, let's say, 10 bits per second. And the second one is to increase, let's say, the capacity of the transmission beyond the 10 terabits per second. So these are the two main novelties, and as you will see later, there are some specific designs within the project that have been carried out. From the networking perspective, let's say, as you can see here on the top, we have, let's say, a 5G/6G network, where it is composed by a remote unit, distributed unit, and centralized unit, and also the core network. So basically, as you can see here, the proposal from FlexScale is mainly covering the backhaul, but also there are some part of the solutions that we are proposing that could also be considered for the midhaul, but basically it's a solution for the backhaul. And as you can also see here, we are also considering the integration with the IP layer. So in such a way that we have an optical layer, and on top we have an IP layer in order to provide the required flows, to provide connectivity between all the required network elements. This is the architecture that we have considered here, without going into details, because I understand that is, let's say, not of interest for many of you, but just to let you know how, let's say, how it works a little bit. So at the top, what we have is some specific new devices that are the wideband selective switches, that basically what allows to switch optical bands independently in such a way that we can route them into any output port. Then we also have a second stage that is related to the fiber switching. And then there is a third stage that is related to the wavelength switching. So basically, the main idea is that, let's say, we increase the dimension of the nodes in order to also allow switching beyond what is the optical wavelength switching, and also consider this wideband switching of fiber switching. So this is one of the, let's say, one of the main novelties that are considered in this project. So now let's go to the specific details on how we can control this technology. So basically, this is the network that we are considering. As said before, it's a multi-layer network where we have an IP layer at the top, and at the bottom we have an optical layer. The optical layer is the one that I mentioned before, with these new devices that allows to increase the capacity at the switching level, but also at the transmission level of the transponder. And then on top, what we have typically are some IP routers that are connected to these optical nodes. So here in this picture, you can see that it's a complete system. So basically means from the antenna sides to the core on the right side. And in between, we have several IP routers that are responsible for aggregating the traffic and basically transporting that to the core network. Here we are using this terminology of HL5, HL43, or 2 or 1, so based on the capacity. But basically, the idea is that this is the typical network that is available for communications. So let's consider an example where we need to provision an optical channel, an IP flow between this node and this node. So typically, it will be routed in the IP layer, and assuming that these IP routers are connected using some logical links. These logical links are deployed in the optical layer. So basically, it means that whenever you want to provision a logical link between a pair of IP routers, first, you also need to deploy an optical channel between these two IP routers. So in this example, as you can see here, if you want to go from this source node to this destination node, we need to involve 3 IP logical links in such a way that the communication goes in this way. So basically, it goes up and down from the IP layer to the optical layer. And this is what is known as an IP of a hop traffic flow. So what we're proposing in FlexScale is the following approach. So instead of, let's say, because the main goal of FlexScale is try to perform an efficient management of the energy. So the goal is try to upload as much as possible the traffic in the IP layer to the optical layer. So that's why the main idea is that in this case, for example, if we want to provision the same flow that we have seen previously, instead of going hop by hop from one IP router to another IP router, what we can do is to dynamically deploy a virtual IP logical link between these 2 IP routers that is provisioned, again, using or deploying an optical channel. So in this way, as you can see here, this IP flow can bypass the previous IP routers that were not used before, and we have a direct link from this point to this point, thanks to the fact that we are basically bypassing the optical flow, the flow to the IP layer, to the optical layer. So this is let's say one of the main features that we are targeting in FlexScale. So to perform an efficient use of the energy by reducing as much as possible the traffic in the IP layer and uploading that to the optical layer. So this is our goal. Okay. So considering that this is the architecture that we have proposed, as you can see on the top, we have an overall management system that is in charge of orchestrating the RAN, also the core network, and the transport network. So this part that is in blue, let's say, is out of the scope of FlexScale. So in FlexScale, we are not dealing with that, but we are considering, let's say, this overall system. So it's a way that whenever we want to provision or to provide a 6G service, we need to involve these 3 segments. So for the transport network, it is a sustainable transport network, sustainable from the point of view that I mentioned before. So try to reduce as much as possible the traffic in the IP layer by uploading that to the optical layer. So the idea is that we have this sustainable transport SDN orchestrator that interfaces with a packet SDN controller and also with an autonomous optical controller, in such a way that we have dedicated controllers for the optical technologies and also for the packet technologies. Then here you can see that the 2 devices that let's say that we are developing FlexScale, the petabit per second optical node and the 10 terabits per second transponder, where this optical SDN controller is responsible for configuring and also for collecting information about these devices. In addition to that, there is also another functionality that is that is related with the collection of the data from these devices and also let's say the analysis of these data. So it is performed by this telemetry manager and these data analytic managers. So the main idea is that these new devices that are going to be developed in FlexScale, we can configure them using this optical SDN controller, but we can also collect the data and also perform some analysis of these data that will trigger some reconfiguration of the network. And then finally, we also have, as you can see in the left side, this commercial equipment that are the IP routers. So IP routers is something that is out of the scope of the project. So let's say this is an overview of the architecture that we are developing the functional architecture that we are developing in FlexScale. So, some more information, and then I will jump to the specific extensions that we are proposing in TeraFlow based on these requirements. So as you can, well, as now I'm gonna let's say describe the interaction between the different switching layers in order to give you, let's say, or show you the complexity of this kind of networks that, as mentioned before, at the optical layer we are dealing with three different switching layers, and then we also need to integrate that with IP layer. So based on that, you can see that here we are considering that at the bottom we have a spatial cross connects that basically can switch a bundle of single mode fibers or ports in a multi-core fibers. Then on top we have waveband cross connects that allows to provide waveband switching. So basically to switch one optical band from one side to another side. Then we have the wavelength switching on top that allows to switch wavelengths. Then we have the transponders, and finally we have the IP routers. So now let's assume that we are going to, well, that we need, let's say, to provision a channel, a flow between this pair of IP routers. So between this one and this one. So before, let's say, provisioning this optical flow, the first step is to provision an optical channel, as you can see here, from this pair of waveband cross connect. So, for example, this spatial channel can be one core or one single mode fiber. Then this spatial channel is represented as a virtual waveband link between this pair of waveband cross connect. Then after that, we need to provision a waveband channel, for example, so between this pair of ROADMs. For example, we need the L band. Then it is represented as a virtual link between this pair of ROADMs. Then we need an optical channel between this pair of transponder. For example, it's an optical channel requiring a metered channel of 75 gigahertz. And it is represented, let's say, as a virtual OTC link. For example, saying that these transponders have a capacity of 800 gigabits per second. Then we provision a digital service connection, for example, of 100 gigabits per second. And finally, we can represent this connection as a virtual packet link between this pair of nodes. So as you can see here, from a control perspective, what we need to, let's say, to manage is extremely complex because it's a multi-layer network. And finally, of course, we can provision the pipe connection. So what are the proposed extensions that we are considering for TeraFlow? So this is the overall picture of TeraFlow release 2. I think you have been discussing that, or at least you are familiar with that you have been working with that all these days, and in fact it was published a long time ago, this one. So I'm not going to spend here time. Yes, my interest is just to show, let's say, these new boxes, let's say, that are the new services or microservices that we are proposing. So basically, you can see here that well, the ones in pink are the new ones, and the ones in blue are those ones that need to be modified. So you can see here, we require, let's say, the extension of a quite large number of services, because our goal, let's say, is to deploy closed loop. Okay, this is our goal in the TeraFlow, in order, let's say, to be able to reconfigure the different switching layers that are involved, as I have explained before. So these are the different elements that we are considering, the new ones. So the end-to-end orchestrator, the optical, in fact, have already been described this morning by Nicola. Also the analytics, the telemetry, the automation. And now, basically, I'm going to explain you, well, I'm going to provide you some more details later on what are the specific functions that they are expected, let's say, for each of them. In addition to that, also let me show you that, as I have said before, the idea is to deploy a control solution for a multi-layer network. In our case, we are considering an end-to-end orchestrator on top, and then there will be dedicated optical SDN controller, and then also an IP SDN controller. So the optical SDN controller, as I said before, is the one that has been presented this morning by Nicola. So now I will, let's say, focus on the other tools. Okay. So this is the closed loop, the ZSM closed loop. So one of the main goals that we have is to introduce a closed loop in TeraFlow in order to manage the different the reconfiguration of the different switching layers that we have seen before. So this is the typical closed loop that I guess that you all are familiar with that. So basically we have the monitoring that is responsible for collecting the data. Then we perform an analysis of this data. And based on that, based on this analysis, let's say we can generate some insights. Then we have a decision model, intelligence model that is responsible for taking the decisions based on the insights that are provided by the analytics model. And finally, we have the execution, control, orchestration that is the one that is responsible for the actual deployment of the reconfiguration of the service based on the decisions that have been taken. So this is the closed loop, the well-known closed loop we define in ZSM. And here you can see the mapping of the let's say of the services that of the components that I showed you before that we are proposing in TeraFlow. Basically, as you can see here, we have the monitoring and telemetry. So these two modules, monitoring and telemetry, are the ones that can be mapped to the monitoring. Later, I will give you some more information about that. Then we have the analytics that it maps basically with the naming using ZSM. Then we have the automation plus policy that in this case is the decision model. So in the proposal, let's say that we are considering for extending TeraFlow, it is a couple into components, automation plus policy. And finally, we have this service and sub interface that it was already existing, so it's not new. That is the execution. Okay, so we're responsible for provisioning the service. Good. So then, here you can see a little bit the interaction between these different, well, among these different components, considering this closed loop. So let's start. Well, basically at the bottom here you have the device. So the entities that can be a device, a controller. In our case, we are also considering a controller. So it's not required to collect the data only from the devices. We may also have another controller we have seen before. So we are considering a hierarchical approach for the control and orchestration system. Then here we have the two models that are used for monitoring. So we have the telemetry and the monitoring. So basically, telemetry is more focused on the data collection itself, let's say on collecting this data, and the monitoring is more focused on the management somehow with data. Okay, so that's why it is split into two models. This is let's say, just to clarify that this is an ongoing work. Maybe of course we are going to modify that in the next weeks, but at least this is, let's say, what has been discussed so far in the framework of our packet 5 in FlexScale. Then on top we have these analytics modules that is responsible for the threshold detection, the forecast logic, and the machine learning algorithms. Okay, and as I said before, it can provide basically insights or events or alarms to the automation model. So in our case, let's say that the decision entity is split into these two components: the automation and the policy. So the automation is responsible for deciding, let's say, the CRUD policies. So the create, read, updates, and delete policies to the policies module, and also to request the KPIs that have to be monitored. And that's all. Yes. And then finally, we have these two more elements, the service and the subbound interface, that I said before are those ones that are related with execution. Okay, so it's the ones that are responsible for the actual deployment of the service. So basically here we have the CRUD services and the service using the service handlers, because of course we may have different services. So then finally we perform the configuration of the rules using the SOAP1 interface. So this is the overall picture, let's say, that has been defined in order to develop this this automation loop. Okay, and this is just to show you also the interaction of that with the two elements, that the two main elements that we have seen before, the optical and the end-to-end orchestrator, because the main idea is that this closed loop can be used both at the optical SDN controller level, but also the end-to-end SDN controller level. So in such a way that we can deploy closed loops at the low level for the optical technologies, but also at the let's say the end-to-end level, combining IP and optics. And I will say that that's all on my side. So thank you very much.